Hey, how's it going? So for the last few days, I've just had this idea in my head of using a DAG, that is a directed acyclic graph, to represent a state in a video game for a dating sim somewhat similar to DDLC, but without the weird fourth wall breaking elements. And I just I can't stop thinking about it, so let's do it. Okay, now first off, we're going to need a template node type. So eventually, I think if I made a video game out of this, I would store the nodes in a SQL database. But just if I'm rapidly prototyping something, I'm probably just going to put it in JSON for the meantime. So the template node is going to... No. Let's not do it like that. Let's say template node is like this. And it's going to have an identifier. And it's going to have is start node, because everything is going to start from the start node, and it's going to end at an end node. Now, originally I was going to have just one end node, and I think that that's a mistake. Especially if I want to have subgraphs, then I need to have multiple end nodes to be different game states that can come out of the subgraph while hiding the different variables. So, is start, is end. Note, mutually exclusive. How are we going to do this? Is start implies not is end, and is end implies not is start. I don't know if that was clear. Okay, let's put down our rules down here. Every node's ID is unique. No duplicates. Okay, autocomplete is kind of creepy, but whatever. Okay, is start and is end cannot both. Oh my god. Cannot both be true. All right. All right. Now we're going to have connections, and there's going to be different kinds of connections. Let's do that one next. So we'll just have this be text, because in the first version of our system, it's just going to be text. Okay. Every node must have every key from template node and no additional keys. 1-to-1 mapping. Okay. Data types must match template node. Alright, so text, so we can't be using none. We have to do it like that because it's going to be a string. Alright, now what else we're gonna have connections, but I haven't quite figured out what those are gonna look like yet. So go like that. Connections. These are going to be the output edges. Yeah. All right. Okay. Is start nodes cannot have inputs. Is end nodes cannot have outputs. All right. Every is Oh, how do I want to word this? How do I, you know what? I want an LLM to help me. Help me figure out how to word this. Is it still recording? My screen thing went away. Okay, yeah. Okay, let's see here. How do I word this? Is start nodes cannot have inputs. Okay, every node that is not a start node must. I think I just answered my own question. Oh well, I'll finish typing it and then I can just copy paste it if I figured it out 100%. Okay, so every node which is not is start must have an input node. Every node which is not is end must have an output. Not node. Edge. Edge. Okay, maybe that already makes sense. Okay, end nodes cannot have output edges. Okay, no inputs greater than one output. No outputs greater than or one input. Trying to figure out what I'm hearing. I think a dog barked. As long as somebody isn't breaking into my house, it's fine. All right. Okay. Start nodes cannot have input edges. Yeah, that's better. Okay. Cannot have output edges. Must have at least one input edge. Okay, and then all edges must be traversable. Note that this, by definition, implies all nodes are visitable. All right. Okay, let's call this output connections. All right. Every node ID. Okay, so far it looks pretty good. Now we need conditional outputs. Okay, I think that we have to. I think that we have to split this up. Output connections. User selectable. Output connections, user selectable, output connections, conditional, use condition true for pass-through. Pass-through. Note that these are ordered. All right. So first true will work. Will fire. Okay. Output connections conditional. All right. Okay. So let's go back over here. Help me define, no, we are not ready yet. Okay. Output connections user selectable. Traversing an edge. Has a destination, node ID, and can increment one or more variables. Variables for this example are merely strings, which will map to values, which will map to 0, what is it, initialized integers. Okay. Help me define a method how would I store options like this? When user selectable, they would have an option text. All right, I think it's just going to be a dictionary, but I want to see what it proposes. Destination, increments. Yeah, I think it has the general idea. Okay, help the merchant. Okay, so okay. So this is how we're going to do this. We are going to say templates output connection user selectable equals, and then is that JSON? I wanted Python. Freaking punk. Okay. Alright, so destination is going to be a node, number 1. Increments is going to be, I like this. I was thinking of like a comma delimited thing, and I think that that would have been a mistake. So yeah. Like this is probably good. Increments. Okay. All right. Text is go to store. Has bread and spent money. Okay, so something like that. All right. Use condition true for pass through. Know that they're ordered, so it's true. All right. Okay. All right. You return that in JSON. Please return only in Python dictionaries. Going forward, look at my revised template. All right. I need conditional format. Please provide a suggestion. It will be similar to Python interpretation, where non-zero can be considered true for the purpose of Boolean evaluation. All right. All right. So it's going to propose something, and I will either think that it's a terrible idea or I'll think it's a good idea. Okay. Template output conditional, destination, increments, condition. Increments, condition has... okay. I probably would have spelled that out. All right. So let's go like this. I think that this looks pretty good, and this is basically what I was thinking. So template, output, connection, conditional, destination 5, increments, quest complete, sounds good to me. And condition is has bread, and gold is greater than. That was weird. I thought it was some Unicode character. Well, whatever. All right. So every node ID is unique. Yeah. Has bread and gold. Okay. Note. Okay. Every variable used in a conditional must appear somewhere in an increment. Otherwise, we could have typos causing errors. All right. Maybe the elaboration is not necessary or helpful, but whatever. I'm doing whatever. Okay. Man, I'm so itchy. Okay, every variable used in conditional must appear somewhere in an increment. Increments. Okay. Yeah. If output connections user selectable is length 0, the following does not apply to is end nodes, since they cannot have outputs. Okay, so either output connections user selectable or output connections conditional must be populated, but not both. All right. A logic engine will determine that conditional connections always have an answer. Always have an answer. Always have a selectable path, and that what? Output connections conditional. A selectable path, and that every path is selectable. Otherwise, there will be an error. No. All right. Look at my spec and see if I am missing any checks for, what am I trying to say? Any checks for a DAG base game state. All right. Scrutinizing DAG game state specification for missing checks. Alright, probably should have run this through Opus instead of Sonnet, but whatever. Well, we'll get a preliminary run through and then I'll have it do a once through. Okay, every destination ID in output connections must reference and okay, at least one. Oh, I meant that, yeah. A node cannot have a destination pointing to itself. I think that's defined in acyclic, but you know what? I'll allow it. That's fine. Condition expressions must not reference undefined variables at evaluation time. They're supposed to be 0. You know what? Let's copy this and okay. You know what? I never really said that it was acyclic. Oh my god. Really? I can't. Okay. That's fine. I just expected to be able to copy everything, but that's fine. Okay, so let's see here. Either... Okay, this is convoluted. Split it into separate statements rather than heading with colon. Okay, well, I'll always have a selectable path. Each node must... Okay. That's fine. That's probably not how I would have done it, but that is fine. All right. I don't really think we need the comment things. Destination validation, graph completeness. Okay, conditional parsing. Let's see what this says. Every destination ID in output connections must reference an existing node. Graph completeness. At least one start node must exist. At least one end node must exist. Great. Node cannot have a destination pointing to itself. No edge can create a cycle in the graph. Note. Cycle detection will be applied naively without consideration for conditional pathing. Verification will run in a two-step process. Preliminary evaluation will naively consider all edges as equal, and then subsequent advanced evaluation will check for traversability of all edges, assuming... Hold on, I need to check the air quality in my house, because, like, I am really itchy, and I'm worried there's something wrong with the air. VOCs are off the charts. Yeah, there's formaldehyde in the air. That's why I'm itching. You know what? Let me go take care of that. Maybe. Where's pause? Pause. Please. All right, I am back, and I have tea, so that's good. All right, let's see here. Empty increment arrays. Are empty increment arrays allowed? Yes, they are. Okay. Condition expressions must not be reference undefined variables at evaluation time. This is not true. Increment variable names should follow a consistent. This is not enforceable. This doesn't. Yeah. Let's say increment variables that appear in a conditional must also appear in an increment. Okay. This will cause an error otherwise. Okay, non-incremented variables will remain 0. Yeah, that sounds right. And then incremented variables which do not appear in a conditional will create a warning, not an error, since this may be valid debugging state. Okay. Okay, user selectable connections must have non-empty text. Fair enough. User selectable connections must each have unique text within the node. For example, you can't have two options that each say go left. Okay. Okay, every node should be reachable from at least one start node. Every node should... Okay, for nodes with only conditional outputs, at least one condition should always be satisfiable. Consider adding a default from... No. Alright. Explicit check that the graph is acyclic. No cycles possible through destinations. All paths end at an end node. Okay. Should variables have min-max limits? Nope. What happens with integer overflow? Well, there's no loops, so we're not gonna have... Okay. Integer storage mechanism should be 32-bit integer or higher, so that overflow is effectively irrelevant, since looping is not permitted. Yeah. Okay, validate that condition strings can be safely parsed, evaluated. Handle malformed expressions gracefully. No. Malformed expressions should cause an error. No arithmetic operations which can fail. Example, node A, no, variable A divided by variable B, since that could be division by 0. No arith, which can fail. Yeah. Okay. Yeah. only allowed are greater than, less than, greater than, equal to, lesser than, or equal to, plus, minus, times, and the operators and, or, not, and parentheses. This should be a valid Python statement lacking more advanced methods or arithmetic or math calls. Alright, empty increment arrays. Are empty increment arrays allowed? Yes. Okay, if there's an ambiguity, empty increment arrays are just fine. Okay. All right. All right. Yeah. This. Okay. Do we want Boolean operations? I think so. Like bitwise crap. No. You know what? No. I don't think that we do. All right. And if there was some weird reason that we needed to do that, we could come back and do it later. So. Oh. Empty increment arrays are just fine. Conditional parsing. True and false are allowed. True and false are allowed. As well as integers. Static integers. What is that called when you declare it? Wow. Oh my god. I swear to God I have a master's degree in computer science. What is it called when you hard code a number in an expression? Like this. A is greater than 4. The 4. I don't know what to call it in the following. Let's see. Okay. That is the context. A literal. Oh my god. Gotta turn in my CS badge or something. As well as integer literals. No floating point numbers are used. Negative numbers are okay. But no variable should be negative, since we can only increment. Okay. All right. Okay, let's. I want to start, just in case it has like a misconception here. Let's start a new chat. How do I hide this? Whatever. All right, we are going to switch to Opus. All right. Look at my specification and see if it makes sense and if it needs revision. This is a DAG which represents game state where every edge is traversable. Traversable. Oh my god. I hope that that's spelled right because I'm adding it to my dictionary. Which every edge is traversable. Whatever. Just let it go. Okay. Based on what this says, I'll bounce it off some other LLMs just to make sure that everything is in order. Okay, scrutinizing specification details and flagging potential issues. I appreciate it. I appreciate all of your hard work. I can see that it's designed for branch narrative, a quest system in which players make choices. Must be traversed. All edges must be. No, that's true. Okay. Alright. It seems to think that this is JavaScript instead of Python. It's sort of weird. Okay, you know what? I think that this text here is good. I don't know if this needs any changes here. So let's take core rules and just copy it wholesale over to here. Okay. This is to define a DAG which defines game state. Note that there are no loops since it is a cyclic, and all edges and nodes are traversable, and that game state is deterministic. Okay. All right. I think this looks pretty good. Yes. We will have a naive pre-check and then a comprehensive logic engine second step, assuming the pre-check passes. The logic engine will not start if all simple conditions are not first verified. Okay, so let's see here. Alright. Explanation equals. Alright. Maybe that's not the best place for an explanation, but whatever. I'm just not too worried about it. Okay, let's come over here. Okay. Look at the following Python code which explains a DAG system. Check the rules to make sure they seem complete, make sense, are clear, etc. Alright. And I think we're getting close. So we will multitask here. All right. Okay, so a few suggested refinements. Your rules cover virtually every dimension of a clean deterministic DAG-based state machine. Few areas to tighten: conditional, edge, text, and exclusivity. Bare variable, allowing them either explicitly or require comparisons. Cycle detections. Please create line items to append to my specification based on the deficiencies you mention, rather than including them elsewhere, so I can see them alone. Okay. Okay. Require each output connections conditional entry to include a non-empty text field and enforce that those texts are unique within the same node. I mean, I thought I said that, but you know what? If I didn't say that, then yes, we definitely did. Conditional edge exclusivity priority. When multiple conditional outputs exist on one node, enforce that their conditions are mutually exclusive. Okay, yeah, that's fine. I mean, from my perspective, that was going to be caught during the logic engine phase where we're checking to make sure that every edge is traversable, but maybe explicitly determining that is fine. Or specify a strict evaluation order to resolve overlaps, which is what we did. They are ordered. We have ordered them. So maybe that is not important. All right. Bare variable tests forbidden. Disallow using a variable name alone in a condition. No. Nope. I straight up disagree with that. Straight up disagree with that. Because I want to be able to use them as Booleans. Because sometimes it's going to be like has key, or it's going to be like likes dogs or something, and it was never supposed to increment and get higher. Okay, require each output connection conditional entry to include a non-empty text field and enforce that those texts are unique within the same node. I thought that was already in there. If it's not, then it needs to be. Conditional edge exclusivity priority. When multiple conditional outputs exist on one node, either enforce that their conditions are mutually exclusive. I don't think that that's necessary. Then specify when multiple conditional outputs exist on a node, keep in mind that they are ordered. So the first true value will be used. The logic engine in the second verification step will verify that each edge can be triggered, including via the order, and that at least one edge can be true by checking for them all being false and failing to find such a case. All right. No, these are good suggestions. Explicit comparison. I haven't written a single conditional yet. No, I'm gonna ignore that one. Define an algorithm starting from an initial state. Simulate traversals. Phase 2 details. I'm gonna worry about phase 2 later. Per start reachability. If multiple start nodes exist, no, they don't. Does it think that multiple start nodes can exist? Let's see what it says here. Start nodes. Is start equals true? Okay. There can be only one start node. There must be exactly one start node. Okay. It worded it differently than I would have, but it did catch that, so... Okay, precise traversal. All edges must be... Every edge must lie on at least one valid start to end path under some reachable game state. Okay. Okay, reach. Okay, every node must... Okay. For step 1 verification, variables and conditionals are not considered for this. For step 2 verification, what? No. For step 2 verification, actual traversals and logic will be used for checking. Alright. Yeah, there's no reason to fire up a freaking logic engine if a node is completely detached or something. Alright, end node output must be empty. Is end equals true, both... Okay, I really think that that's in there already, unless Claude deleted it. Output must have exactly one type of output. Okay, for all non-end nodes. Okay. End nodes have no output connections. Yes. No node output can connect to a start node. In other words, no start node can have an input edge. Makes sense to me. All right. Numeric increment syntax clear. No. Yes, all variables in increment can only appear once. In other words, in other words, you cannot increment something by 2 by having it twice. All right. Okay, operator precedence guidance. Document or reference the exact precedence rules. Yes. Okay. After verifying that logic is correct and that no methods are invoked and arithmetic is safe, Standard precedence rules apply for conditional evaluation. Just like using Python eval. Okay. So dead-end paths as errors. Elevate non-end nodes with no satisfiable exit conditions, preventing unfinishable game states. I thought it was. Okay. Warnings. Dead-end paths. Unreachable conditions. Errors. Incremented but never checked. Okay. Claude modified that. I do not agree with the changes. I should not have run these both at the same time. Let's start over again. New. All right. The following is Python code explaining how nodes will interact with each other. Check the specification for the DAG game state and make sure you see no issues that could make it problematic or allow for an invalid state. Okay. So I'm hoping that we're getting close because this is taking longer than I thought it would. Okay. Now let's make sure. Do we have yes. Every node must have every key as defined by the template. Every conditional should be a dict with the keys and data types as defined by their respective templates. Okay. Yeah. Every node must have every key as defined by the template. The values should match the data type provided in the template as well. Okay. So we're going to have like a multi-step verification. There's going to be no orphan nodes. Everything is traversable. Then we'll go through and we'll want to make sure that we have hit every single one of these conditions. All right, and let's come in here. That's still generating? Oh my God. I've analyzed the Python code. Of course. The specification is well structured and covers many critical aspects of ensuring a valid and deterministic game state, such as unique IDs, node type constraints, and separation of user selectable versus conditional paths. The two-phase validation approach is also a robust strategy. I have identified several issues, ranging from direct contradictions to ambiguities to potential loopholes that could allow for invalid or problematic statements. These are direct contradictions within the specification that must be. Okay, the same variable can appear multiple times in an increment line. I sort of made that shit up. Am I making a mistake? No, I'm not making a mistake, because if I truly want to increment a variable multiple times, I can have a do nothing node. Okay. Note that empty text nodes for control are acceptable. Okay. Alright. All variables in increment can only appear once. In other words, you cannot increment something. Yes. Adopt the second, more restrictive rule. This is cleaner. No. Start node cardinality. The rules for the number of nodes are contradictory. Must be exactly one, at least one. This is not accurate. Okay. Exactly one. If this appears twice, then there must be exactly one start node. We don't need to mention that twice. If I could stop doing that, that would be great. All right. Okay, incomplete conditional connection template. The rules were updated to require text fields for conditional outputs, but the template was not. Require each output connection conditional entry to include a non-empty. That is absolutely not correct. Okay, require each output connection conditional entry to include a non-empty text field and enforce that those texts are unique within the same node. This was supposed to be template output connection user selectable. I just said the wrong damn thing. All right. Comment. All right. Okay. The comment text field in conditional edge is merely a convenience for reading the graph and be used to annotate control paths, but is not necessary. In other words, empty or empty. Multiple empties are acceptable, but populated text values should be unique within the node. I should have trusted the autocomplete. It knew what it was talking about. Okay. Okay, a template is missing. No, it really isn't. Okay. Potential for logic dead ends. A node with only output connections conditional can become a dead end if the player arrives in a state where no conditions evaluate. That is true, but that should be picked up by the logic engine in stage 2. So either output connections, user selectable, has content, or... Okay. Yeah, in... Verify that considering conditional logic, no infinite loops are possible. Phase 2, check that... Oh my god. Check that output connections conditional is every edge is traversable and no case exists where all edges evaluate faults. Okay. That probably doesn't go in there because it's not cycle detection. Alright, that might be redundant, but that's fine. Okay. Ambiguity of integer type and overflow. The specification states that variables are 32-bit integers or higher. This ambiguity is dangerous. If using fixed integer size, the increment-only rule can be violated by integer overflow. Become a negative notice. Explicitly state our arbitrary precision integers. No, I'm not going to make them arbitrary precision integers if I'm only incrementing by one at a time. That's stupid. That is just absolute nonsense. All right. Must be a valid. Okay. Okay, specification has 2 points that are difficult to reliably implement. Conditional coverage, generating a warning if no condition can be satisfied from the initial state. The condition might be unsatisfiable at state 0, but become valid later. What the hell does that mean? The check needs to consider all reachable variable states for that node. Oh, shit. I did not write that. That's what I get for trusting LLMs. Okay, for nodes with only conditional outputs. No, I wrote it up above. That whole line is just stupid. Okay, logic engine must verify that all edges are theoretically traversable. This is a very complex requirement. Given the variables only incremented is simpler than the general case, but can still be non-trivial. I know, that's why I'm going to use an engine. I'm not going to create it from scratch. Clarify the scope of the logic engine's validation. Instead of a perfect is this theoretically traversable check, which can be computationally expensive. Consider a more practical heuristic-based approach. The engine traces paths from the start. It calculates the minimum possible variable values required in a given node. For a conditional edge, it checks if its condition is satisfiable given the maximum possible variable values accumulated on any path leading to it. This provides a stronger guarantee than checking from state 0. I agree. I didn't write that shit. That shit is ridiculous. So yeah. Okay. Okay. Okay, so the multi-stage verification is like so. Okay, in number 1, we are going to check all nodes naively for compliance, including input and output, tags, no duplicate text, etc. Okay, and then we, yeah. Okay, and then step 2 is we do a depth first search, attempting every path, which is possible based on conditionals. Yes. Maintain a list of all non-executed edges. Immediately stop if a conditional branch fails. Yeah. We check for simple cycles. Yeah. No cycles. We do a depth first search attempting every path, which is possible based on conditionals. But stopping if a node is encountered twice. Maintain the list of all non-executed edges. Immediately stop. No branch fails. All right, 4. Okay. After doing all preliminary checks, we invoke an external logic engine to verify remaining conditions. All right. Okay. Template node and then assert. Assertions like that. Yeah. Okay, so assertions. Okay. Assertions is a list of things which must evaluate to true, or else something is wrong in the graph. Yeah. These follow the same format as conditional branches evaluating to Boolean. Okay, we do a depth first search. Also fail if an assertion is false. Okay, after doing preliminary checks, we invoke an external logic engine to verify remaining conditions, including conditional branches and if it's possible for assertions to be false. All right. Edit. Don't tell me it's misspelled and then don't give me a... Alright, I think that this looks pretty good. What did I just do? Okay, look at the revised spec. You know what? I'm going to give it in the same format as before. Okay, I have added the assertions. I think it looks pretty good. A few items still need tightening up. You've added assertions, but there's no template for what an assertion looks like. Okay. No. I don't mind giving an example, but like an example would be has bread plus is hungry. Ate bread plus is hungry is greater than 0. Okay. So, either you ate bread or you're hungry. Okay, assertion. Here is an example assertion. Implying that for the current node, either the variable ate bread has been incremented or is hungry has been incremented. I think it can infer what is meant. Placement of empty text nodes. Note that empty text nodes for control are acceptable. It really belongs under the text validation and node structure. Nodes which have an empty text field. Yes. Empty. Note that empty text nodes for control are acceptable. And where did it say that it should go? Seems a little pedantic, but ask ChatGPT inside of... Oh! Thought I was using Gemini. Okay, well, whatever. Alright. Nodes may have an empty text. Text validation or node structure. Node structure. Note that empty text nodes for control are acceptable. Yeah, just are acceptable. Just whatever. All right. But they cannot have user selectable options inside them since they are passed over. Hopefully I don't regret typing that later. Conditional edge descriptions label. The item currently titled Conditional Edge Description actually refers to user selectable edges. User selectable edges. Every must have a non-empty text. Must have a not. Every entry in. I hate you so much. You will never know. Must be unique. Okay. User selectable connections must have non-empty text. User selectable connection text must be unique within a node. That is true, but it's saying it's in the wrong select section, right? Append or replace existing. User selectable edge text validation. whatever. I'm starting to not care. Numeric increments and single-use rule. You've added all variables an increment can only appear once, but never clarify if you support numerical increments. No. I do not. Am I being a hard ass about this and I regret it? I mean, think about it. What if... Damn it. Why am I being ridiculous about this? Okay, okay. Okay. Only once. Only once. Only. Alright, at least one edge node can be true. It doesn't make any freaking sense. Okay. Okay. Okay, go back, go back, go back, go back, go back. Okay, if you add n units, increment syntax. After a colon. Example, gold 10 or 8 bread. Okay. All edges must be traversable. You now split step 1, but the top level graph property still says all edges must be traversable. They must be traversable. Treat every edge as unconditional and okay. I thought I said that, but you know what? If it is, if it's confused still, then yeah, that's fine. All right, depth first verification algorithm. Step 3 is a bit terse and mixes warning and error. Spell them out formally. Phase 2 DFS algorithm. Start at the edge with all variables equal 0. At each node, evaluate its outgoing edges in declared order. If user selectable, always traversable. If conditional, only traversable. Its condition is true in current state, and it's the first one. Okay, so depth first. Yeah. That was a little. Phase 2. Okay, upon taking an edge, if you revisit a node in the same variable state tuple, flag a conditional cycle error. If you exhaust all edges at a node without success, flag a dead end error. If any assertion at a visited node evaluates to false, flag assertion error. Okay, that's fine. Yeah. Phase, let's call this step 3. Step 3, depth first search algorithm. All right. Operator precedence reference. Rather than standard precedence link explicitly to Python's rules, avoid ambiguity. Operator. I hate this. Precedence. After verifying that logic is correct and that methods are invoked and arithmetic is safe, standard precedence rules. Operator. Okay, that's fine. I navigate to that. Okay. But note that we are using a subset of the available arithmetic operators. Okay. Arith operators. Subset of the available operators. Okay, so still think it seems a little messy, but yeah. All right, now we need to declare. Yeah. So we will need some sort of an engine which takes a file and applies all of these rules to verify it. So let's do that. Okay, so we will have a new directory called graphs, I guess. These are dictionaries. That's fine. That's fine. We just need to map them. Okay, so the most basic possible, well, let's not do the most basic. We will do a file, and then we will call it basic.json, like this, right? And hold on, I need a scratch pad. Scratch pad. Okay. Okay, so template node. And so data equals boom, boom, like that. And then we will have one template node, two template nodes, three template nodes, right? Now, is start is true, and is end is true, and then we're going on an adventure. Output connections user selectable is, there is no output connections conditional. There just isn't. Output connections user selectable. No, this is automatic. We automatically progress. So conditional, like this. Output connections user selectable, conditional, and then the condition is true, and then doesn't increment anything, and the destination is 2. Yeah, that looks pretty good. We're going on an adventure. Would you like to go on an adventure? Okay. User selectable. So, God, this is tedious. This is awful. Wow. Yeah. So, would you like to go on an adventure? Output connections users selectable. And destination. We're going to have 2 end nodes. Okay, so 1, 2, 3, 4. Would you like to go on an adventure? And I want to increment something. It's okay. This is our most simple one. Would destination is 3. The text is yes, and then destination is 4. Text is no. Right? Okay. Your life remains boring. Adventure awaits. Okay. Please auto-format. I need you to auto-format. I hate you so much. I hate you more than you will ever know. Print data. That is awful. JSON dot dump s data comma indent equals 4 import JSON. I don't know if we still need these. Three. Okay, let's see what that does. Run. Okay. So. Okay, so we're going on an adventure. Would you like to go on an adventure? 3, 4. Oh, no assertions. No assertions. Now let's make sure that this converts back and forth no problem. So JSON text equals this, and then revert dict equals JSON dot load string JSON text, and then assert. Assert what? Assert revert dict equals data. So we'll see if something... Okay. So we are able to go... No assertions. All right. You know what? We can have an assertion. We can have an assertion. Let's do this. So call to adventure is true. Then would you like to go on an adventure? Increments adventure increments okay, destination 3 boring Okay, and then we can have down here, we can have assertions. What did I push to make it do that? Okay, so 3 is adventure and call to adventure. And not boring. Oh, sorry. Not boring. And then here we have boring and call to adventure and not adventure. Okay. Run. Alright, this is pretty simple here. Okay. Just do a quick look at my example game state. Check for any problems. Note. I am not looking for you to apply every rule. Just verify the structure makes sense. Okay, aside from the assertions block, everything else lines up with your template and core rules. The only issue I see here, assertion entries don't match the template. But per the spec, it should be a dict. I never wanted it to be a dict. Did I say a dict? I think it wanted me to make it a dict. Assertion must be a dict. You're a dict. Alright, okay. Assertions. This is, I wanted to look here. Okay. Assertions is a list of things which must evaluate true. Alright. It told me to change it, and I never changed it, so that's fine. Operator case. Sure, whatever. No bare variable test. You need something. Did I say no bare variable tests? I think it wanted me to, and I told it to go F itself. Okay, let's go back here. This is absolutely valid. Okay, call to adventure and not adventure, boring. This could probably be combined and not boring, but I want to demonstrate that there can be multiple. Okay. All right, DAG main. Let's rename this to DAG spec. Okay. don't know which one of these would be best. I am assuming that it's probably going to be Claude, but I think that I think any of them can do this. So let's bring it up. Okay, step 3. Steps 1, 2, and 3. All right. Okay. Write a class for verifying a JSON document which should load into a list of dicks and match the following specification. Only implement steps 1, 2, and 3 of the verification. We will leave external validation with a logic engine. Step 4 to a future prompt. All right. Okay. The verification should take a JSON file and return errors and warnings. Return errors and warnings. Invalid data should cause an error to appear but should not crash. This includes failure to read the file. Invalid node or file format should fail early and not continue processing. So I'm curious what it's going to do with this specification. I don't know. I've never attempted to have something this complicated before just be generated. What gives me hope is that this is a fairly self-contained problem. Maybe there's a lot of steps, but it's generally self-contained. All right, DAG validator. Okay, load JSON. I feel like this is going to require multiple steps, and I didn't switch it to Opus. Damn it. All right, no, that's fine. I meant to, but whatever. I mean, it's too late now. Well, it's not really too late, but whatever. I'll see what this does. All right, let's see what it did. Oh, did it hit a token limit or something? I've created a comprehensive DAG validator class that implements steps 1 to 3 of the verification process as specified. Here's what it validates. Validates JSON file format and node structure, ensures nodes follow the exact template and correct data types. Checks unique IDs and valid destination references, enforces start-end node constraints, no cycles to start nodes, etc., Validates output connection rules, exactly one per node type. Checks variable naming conventions. Nice. I don't remember specifying that, but I appreciate it. Validates increment syntax. Ensures user selectable texts are non-empty and unique within nodes. Verifies all variables used in conditions are defined somewhere. Simple cycle detection. Treats all edges as unconditional and checks for cycles. Uses depth first search with color coding for efficient cycle detection. With state tracking. Simulates traversal starting from start node with variable 0. Tracks node ID, variable state, pairs detect conditional cycles. Cycles? Whatever. Evaluates conditional edges in order. First true condition wins. Detects dead ends where non-end nodes have no valid exit paths. Validates assertions at each visited node. Properly applies increments when traversing edges. Yeah, the validator handles all error conditions gracefully without crashing. Okay, let's see. Oh my god. I know that there's some stigma around vibe coding, but I mean, if this works, like this would take me a while to do. Not saying it's impossible or anything like that, but it would take me a while to do. So DAG spec, and now we're going to have DAG verifier.py. All right. Game. All right. Let's graphs basic.json. You think this is going to work? Error evaluate an assertion at node 3. Boring is not defined. Yes, error evaluating assertion at node 4. Call to adventure. Alright, sorry, I'm getting a text. I should pause this. Alright, okay. Now it's recording, yeah. I don't actually remember the circumstances walking away from this. I remember that I was trying to figure out how to make it default everything. Adventure is not defined. That is true. But it shouldn't need to be defined. Everything should initialize to 0. So, error evaluating the assertion. But it's going to be the same thing for conditionals, right? Okay. Eval context, eval updates. Where is the assertion being generated? Hopefully I can find this. No, I cannot. It would have to be part of a string. Man. I would prefer to avoid this, but where can I modify it so that it should error if it's not defined anywhere. If it's not defined or referenced, but not if it's merely not updated. Okay. This is pretty close, I think. You need to modify the evaluation context in the depth first search traversal to include all variables defined in the graph, defaulting them to 0. The issue is that the current code only includes variables that have been incremented during traversal. I kind of picked up on that. I just couldn't see where to fix it. Okay, here's the fix. Alright. I can't scroll while it's doing this. I probably can. I just have to click. Okay, let's see here. I'll just let it do its thing. There is no escape from justice, nowhere to hide from your fate. Sorry. Alright. DAG game state validator. Yeah, well, this is something that I'm going to run once. This is not like a piece of code that I'm going to maintain. Ha! Famous last words for any piece of code that gets written. Yeah, but I mean, the validator is for the design phase. It would still require maintenance. It would. I'm sorry. I added instance variable self all variables to track. All right. Let's see if it works. Okay, so DAG verifier. Pretty sure we're going to end up with 2 example usages, which is perfectly fine. All right. For a second, I thought the whole thing was indented. It's kind of weird. What is going on here? What? Oh, I was not expecting these things. That was certainly easy enough to fix. Is this like what in the hell? Well, this is a very simple mistake. Okay, let's see. Like that, I guess. I don't know. It's like I can fix one thing, but I can't. If there's hundreds of things like that, then it's a problem. Where is it getting gamegraph.json? Yay, validation passed. Okay. Okay, let's get a second opinion. Okay, we'll come over here, new chat. Look at my DAG game state verifier code. Boom. All right, now I'll come over here and I'll say, wait, where was I? Now look at my spec. Verify that this code does every check except the final logic engine step. I'll see what it says. I don't actually think this is the kind of question that large language models are good at. But if it says there is a, very clear omission, then we can put that to the test. I need to create a series of effectively unit tests. To verify that this is behaving as expected. And I sure as hell don't want to do that by hand. Based on a detailed analysis of your DAG validator class, the code is comprehensive and correctly implements a wide variety of checks for verifying DAG-based game state. It successfully covers the 3 major validation steps described in its own documentation. LLM's got another LLM's back. Possible gaps. Your verifier is very robust, but there's one common check that is not explicitly performed. Unreachable node detection. The script does not check for or warn about nodes that are structurally valid but can never be reached from its start node. While not always a critical error, this is a sign of an improperly designed. All nodes are reachable. Yeah. You said all nodes are reachable is not checked, but is all edges reachable? Based on the constraints of the graph, this would be sufficient to ensure all nodes are reachable. Based on the constraints of the graph, this would be sufficient to ensure all nodes are reachable. That is true. That is something I had to reflect on and come to the conclusion of, but it does seem to be the case. You've correctly identified logical connection between edge reachability and node reachability. Let's break this down. La da 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 da. Oh my god. Never flag that edge B is unreachable. Well, crap. How do we fix the code to check for all edge and node reachability? Also ensure that every non-start node has an out edge. Every non-end node has an input edge and output edge. This check may already there. Okay. Okay, let's see what it does. It's pretty cool, but we still need to implement the logic engine thing. Which, I'm going to be honest, I have no idea how to do that. I'm going to go put some lotion on. I'll be right back. Okay, you'll have to forgive me. I did scroll down to see this, but it gave me a lot of data, but I don't think that all of it is necessary, so let's see here. Okay, new method for reachability. New vars. Let's see. Return new vars. Oh, okay. Seems like a very logical place to insert something. Let's make sure that the indent is correct. Looks like it is. Verify reachability. And then let's find out where this is called over here. One. Okay, let's see. Okay, so it is a final step. Nice. Run. Okay. And we need unit tests. I wonder if it can do it. Okay. Let's see what it can do. I am going to make a new file called DAG verifier unit tests.py. Would it make more sense to have a hard-coded file or to have a remote file that is called? It seems like it's going to become incredibly cumbersome no matter how I do this. The decision touches on a core principle of effective software testing. DAG verifier unit tests, you should absolutely use local hard-coded files that are stored within your project's repository. Calling a remote file is an anti-pattern for unit tests. It seems like these two lines contradict each other. Am I being dumb? For DAG verify unit test, you should use local hard-coded files that are stored within your project's repo. Oh, remote. Local remote. Okay, I see what it's saying. Why local files are essential for unit tests. But that's not what I was asking. I was asking, should the bad case be embedded inside of that? It doesn't matter. Okay. create test DAG verifier. Unit test.test case. Robust, reliable, professional unit tests use local files included. Can you rewrite that to use PyTest, please? I think I've been tainted. All right. New Python file. And what is it? It's going to be DAG verifier unit tests.py. Yeah, I use PyTest. I do not use that unit test BS. So let's see. Do we really need a fixture? It just seems like standalone tests. Whatever. Okay. I'd better have PyTest installed. If I don't, then we'll deal with it, I guess. Whatever. Spoke too soon. I'm trying to import DAG validator. Well, it's not though, it's DAG verifier. DAG validator. Yeah, okay, no, actually that kind of makes sense. So let's see here. Test graph is cycle. Error, dead end. Okay. Okay. Review the spec and ensure there is at least one test case for every condition, not including the things requiring the actual logic engine, which is not included. Review the spec and ensure that there is at least one test case for every condition, not including the things required the actual logic engine, which is not implemented yet. Okay. I will have you know that I am not manually creating every one of those. Okay. File contains malformed JSON. The root of the JSON file is a dictionary, not a list. The JSON file contains an empty list. Oh my God. Holy shit. By adding tests for these static conditions, you build a powerful safety net that ensures the structural integrity of your game state files. Okay. Here's a list of validation conditions that are not currently covered by a dedicated test case. Here's how you can implement a few of them. I don't really want to do them one at a time. I want to... Okay. We will figure this out. File contains malformed JSON. The root of the JSON file is a dictionary, not a list. The JSON file contains an empty list. I could implement each of these, but I would much rather that they be done for me. So let's see what we can do. DAG verifier unit tests, test file not found. Okay. Can I just run this? I want to know if I can run this. Run. No. No, I cannot. Okay. Scratchpad. Everything. We don't really need that. We don't need that. We don't need that. Split for I in everything. Okay. If dot JSON in I, then print I. So we will extract these individual tests here. Right. Okay. Assert I dot count equals 1. No. Is that the only one? Okay, we're going to say is start, Control R, just is start, replace all. Is end, same thing, is end, replace all. Okay. Maybe I shouldn't have changed it. Okay. I r equals I dot strip dot split. Okay, so file name equals ir dot pop 0, and then description equals dot join ir. Yes. Okay, so print and then file name. I have no idea what I hit to make it do that. Run that. Were there carriage returns in here? IR equals I dot strip. Where's the... A variable name does not follow the all caps convention. Let me get rid of that. Okay. So let's come over here and guess we're going to need... yeah. File not found in... yeah. So template equals okay, test the response. This is going to be the description, and then test file not found. It's going to be unit tests / file name, and then truncated file name equals file name dot split period first part replace error underscore with not that, with test, then assert re dot match, I don't know, start of string, A to Z, A to Z underscore plus $, comma, truncated file name. And if it is not, then show me what it is. Let's see if there's going to be an assertion. I'd like to know right now. Okay, then this is going to be the truncated file name. It's going to be that. We're going to run the validator, length, number of errors, and we don't know what the results are going to be. File not found. I don't know what to put right here. Okay. So let's see what this says. Okay, so our assertions go down here. All right. Now we just need we need AI to create these bad cases. Test not a list. Assert truncated file name dot starts with test, which I'm not sure that it does. Well, I don't want the truncated file name. I want the whole line. Warn unused variable. A variable is incremented but never used in any condition or assertion. All right, sweet. We have templates here. We need the assertions for each of these. Okay, we have to ask AI for these. How do I do that? Hell if I know. Okay. I'll have to get my API key. We want to ask AI. Yeah, I just usually have the file right here. d:\code. There should be somewhere an ask chat GPT. What's that? What are you? Okay. Control C, Control V. Okay, Claude handler. It can be Claude, I don't care. Oh. libproc. Open containing folder, open file location, that's what it is. libproc. And then we want Claude handler. Paste there. And then we want keys. Paste there. Okay. So that definitely needs to be installed. Ask LLM. Install. The hell is this? Oh shit. This is from a really old version, like right when I was first starting to write Weight of Shadows. Wow. Yeah, I've come a long way since then. Okay. Yeah. The Claude handler. Go to declaration. I don't want Claude 3. I just don't. Here, I will, I'll just ask Claude to update it. Hi, this is old. Please update it to use Claude for Opus by default. It's kind of frustrating not having an AI call ready. Maybe I should be a little bit more proficient with this. Searching the web. Okay. Go here to setup. I don't think that will be necessary. Oh, nice. That is exactly what I wanted it to look up. And it automatically set the temperature for me. Pricing remains the same, i.e. expensive as shit. Maybe we should see if Sonnet will work. Well, 1 million tokens is also quite a bit though too. $75? Well, let's see if it works. I can make one call. All right, Claude Handler. Ask LLM. This is a test of an API call. Please confirm you understand. Okay. I'm receiving your communication clearly, and I'm ready to assist you with whatever you need. All right. So we need it to return test, and we need it to return a JSON file. I need more water. Well, I'm getting kind of sick of this. Okay. So I need to come over here to my scratch pad and then import ask LLM. LLM equals Claude Handler. It's right there. And okay, we need a template. So question. Okay. I need you to write a PyTest unit test for verifying failed conditions in my DAG verifier suite. Okay, I need you to write PyTest unit test for verifying failed conditions in my DAG verifier suite. I really think like I need to give it the specifications. So here's the specifications. Okay. Here are the specifications. Boom. Okay. Here is a JSON example of a valid DAG game state graph. All right. Here is the current unit test we are trying to write. That was this type F. Yes, it was. Here is the current unit test we are trying to write. note that the assertions are commented out and probably not relevant to this, i.e. placeholders. Okay. Your job is to fix the test, adding the correct assertions. Do not change the description or the name of the test. And to generate the JSON file needed to simulate the failure condition. All right. Return the JSON file between tags and return the Python method declaration between Python tags. All right. No, this is JSON and Python okay. This definitely needs to be Sonnet because this could really go wrong. Go to declaration. I mean, the price difference is just absolutely astronomical. So, yeah, if I'm not damn sure, then okay. So we're going to say llm.ask question model equals that response print response. Let's see what this does and then break. So if this works, then I understand you're testing an API call, and I'm confirming that I've received and understood your message. The connection appears to be working properly. Wait, what? God. We need the Claude handler is what we need. Ask LLM goes away. So, delete anyway. That was really dumb. Okay. Okay, invalid format specifier, call to adventure. Value error. Oh, imbecile. Okay. Wasn't it? Okay, so the question okay, so that didn't work because it's supposed to be stop helping me. Okay, so template. Okay, just show me the question first, and then let's make sure there's no other print statements here. And let's see what the question is. Okay, so I need you to write a PyTest unit test for verify and fail conditions in my DAG verifier suite. Here's the specifications. Yeah. Here is a JSON example of a valid DAG game state graph. Okay, and then here's the current unit test we're trying to write. Note that the assertions are commented out and probably not relevant to the current test, i.e. placeholders. Your job is to fix the test, adding the correct assertions. Do not change the description or name of the test. And to generate the JSON file needed to simulate the failure condition. Return the JSON between JSON and return the Python method declaration between Python. Okay. No need to elaborate or explain your reasoning. Okay. Just return JSON and Python. Okay. Let's see how it handles this. And then we'll go from there. If we can get most of the way there, then I think we'll be doing all right. Okay, so Python, JSON in error, parser malformed. Yeah, file contains malformed JSON. And you know what? We might need to fix this, but that is okay. Oh, what did I do? Okay, pausing the recording was probably overkill. I just hit the microphone button. All right. Okay, so looks like this worked. Invalid JSON, missing closing bracket. All right. So what does this look like? Not assert. Okay. P1 equals response dot find JSON. Okay. Well, that's impressive. Okay, so if P1 dot count of JSON equals 1 and P2 is greater than P1 and P1 dot count. Thank you. And oh wait. What am I doing? 3, then everything's good, right? Else print. Yeah, that's exactly what I want. Wrong. Print response. Okay. Let's come over here. Okay. Modify this to extract the text between the XML style brackets. Note that this is not true XML, so just treat as a string and trim the output. Oh God, I should have given it the definition of what P1 and P2 are. This is fine. This is fine. This is exactly what I wanted. All right. We will see. Okay. So we should have unit tests / I thought I made that folder, but maybe not. Okay, validator, file name. So where is it? File name is right here. Write the file. Let's do it with open unit tests file name. Write as ff dot, well, write JSON text. That's easy enough. And append. Okay. Unit test text.py. I don't know if that's really the best name, but whatever. New Python file. Just see what it does. Plus, we don't want we want Python text. Yippee-ki-yay. Okay, open in Explorer. Malformed. Oh no, I had the break in there. Error invalid JSON. Did I still print? No, we should not print the response. Oh, nice. Okay. Okay, So what was the error? It tried really hard. Okay, let's see what it does. Insertion error. Where is result errors? Type error. Result warnings. Result errors. Result errors is a string, not list. It's a string. In results warnings. Yeah. Let's do this. Errors equals results errors. Okay. Why is this angry? So it was a list of strings. File not found. Unit tests invalid JSON. Unit tests error invalid JSON. Come back. So yeah, so the file that we wrote was fn, right? Fn is ir.pop error invalid JSON, error invalid JSON. So DAG verifier. Where the hell am I? Here. Okay, so the LLM just decided to rename it. I don't think the prompt was wrong. Okay, JSON. Can only concatenate string. So it sort of was right? Let's just come down here. JSON. Run. Print errors. I'm just curious. Invalid JSON format, expecting delimiter. Yeah. Okay. That worked. Okay, let's come back in here to, I guess we were in Scratchpad, weren't we? Yeah, let's see, no lab, just return JSON and Python. Do not change the name of the JSON file in your test. And let's make sure that we use the fully qualified name here so that it is not our fault. Right here, file name. Okay. Don't get nervous now. Okay. Why have we not made more unit test files? I am becoming increasingly worried. Unit. Oh no. No. Non-existent file. You know, I'm supposed to have qualified these, and apparently I failed. So let's come back here to Scratchpad, and that one is correct. This one is not. And the reason is right here. See, change color. Oh, yeah. Well, and to be completely honest, we didn't need to. Doesn't matter. Does not matter. Okay. Do something with the response. Okay. I have this block of Python code which does LLM queries one at a time. Can you make this non-blocking while still allowing local variables, for example, file name, to get through? like 10 different ones. I don't need multiple ways, but process your single LL inquiry asynchronously. Option 1. You know what? By the time I make it asynchronous, it's just going to be... It would be quicker to just run it. Let's watch it as it goes. Unit test error invalid JSON. Cool. Not a list. Yeah, generating these by hand would have really sucked. But we definitely need code to validate the behaviors, so I do think that there's valid use. Well, I'm going to be honest, this took a lot longer than I thought. I still haven't implemented the logic engine yet. I don't know how easy that's going to be, just tying it to an external system. I do not think I'm going to be getting a text-based prototype of using this engine up this weekend. That's probably to be expected, but still. Okay. Okay. So we're here. Oh, here we go. Twenty-four different test cases. And we are to 19, so we're getting pretty close. Life is pain. I wonder how many of these will just work. Presumably pretty low, because it did not have the source code to go off of. So let's go into unit tests here and cut. Over here. And run this. 21 passed. That is absolutely impressive. Okay, unused variable. Which ones failed? Well, I mean, it failed because basic valid. So unit tests, basic valid, run. 1 does not equal 0. What in the hell? Okay, file not found. Unit tests. Basic valid.json. Basic underscore. Oh. Maybe I am too tired to continue work on this. File not found. Valid basic.json. Well, I changed it. I thought I changed it. Did I copy and paste the same thing? That would be pretty stupid. All right. Basic underscore valid.json. Basic underscore valid.json. Unit tests. Did I like type this wrong or something? Basic underscore valid.json. Taking me to a line that doesn't exist, and I don't really know how to deal with that. Debug. Step into. What is that? Well, how did any of these pass? Okay. Run. I would like to see this. Results, errors, Node list cannot be empty. All right. Graph with cycle. Yeah. So cycle detected in graph. Do we want to try to create these ourselves? I don't think so, no. Dead end, unreachable, not a list. Oh. Non-existent file. This one actually works. Not a list. Yeah, if this it makes sense that it would work. So put this up here and this. Yeah. Unreachable, not a list. JSON parser malformed. Okay, so these are legitimate failures of things that it did down here. So let's see here. Debug. Results. JSON must contain a list of nodes. Copy value. Do you run? Stop and rerun. Passed. Yeah, we can deal with these. Start nodes. Graph has more than one start nodes. Let's see what that means. Error multiple start nodes .json. Control R. Multiple start nodes. Let's see. Unit tests, error multiple start nodes. Error multiple start nodes. Is start exactly what we were concerned about. So let's see here. Errors must have exactly one start node. The list of a string. I mean, it seems like we could just say that work? That does work. Okay. Test node not dict. Same thing. Hope I'm getting a little bit better at this. Debug. So results. str object has no attribute. Get. Okay. Alright. Honestly, kind of seems like it dropped the ball here. So let's see what we can do. Yeah, step into load JSON. Is not instance. This is exactly what we were expecting. If not data. Okay. Can't really enumerate it. It should have failed before now. How do I get back to where I was? Oh, that was useless. Yeah, if it didn't load. Validate structure. Go to declaration. If it's not an instance of a dictionary. Okay. I think that's supposed to be return. So run, and it passes. Cool. That is awesome. Okay, test with that end just does not exist. Test graph with unreachable node. I feel like these would be pretty easy to implement rather than trying to get the LLM to do it for us. Test bad increment syntax. Score foo. Okay. Test graph with cycle. This is just absolutely trivial. So CV paste basic valid. I didn't want basic valid though. I wanted. Oh, I see. Error cycle. Yeah. Destinations. Error cycle, run. Cycle detected in range. Oh. Yeah, where did I put it? Error cycle. Suppose that is a legitimate thing. And we have node 2 has self-reference. Okay, you know what? We're going to call this cycle. Unit tests. Self-reference. Okay. Wait. Don't delete on me, please. Okay, self-reference is treated as separate. So we're going to have to get more clever here. Node 10. Node 10, except that it goes back to node 2. Okay. Unit tests, run. Test graph with cycle. Cycle detected in graph. Cool. Let's see how many there are. Test graph with dead end. Yeah. Okay, so this is going to be error, dead end, like this. And then instead of a cycle, well, that's going to violate the no output nodes. I don't know if that's possible to test. Well, as long as it fails somehow. Output connections to users selectable. Okay. Dead end detected. To get the data out of this somehow. Run. Gotta be honest, not 100% sure what's going on here. Error underscore dead underscore end dot JSON. For I in range 50, print results. Non-endNode 10 must have output. You can't get a dead end if everything has an output. Maybe that's sufficient. It did pass. Okay, node unit test. Unreachable node. Okay, warn unreachable node. Come back here and run. Unreachable node. Non-endNode 10 must have output connections. That's good enough. It has to be so warn unreachable. Warn unreachable node 2. Okay. Output connections user selectable. Output connections user selectable. Test graph with an unreachable node. Must have output connections. Sure you don't work? Unreachable node 2. Wait, I thought that was unreachable node 1. Must have output connections. All right. Test graph with unreachable node. Non-endNode 10 must have output connections. I think that we are supposed to treat this as a warning, or I mean an error, excuse me. Test bad increment syntax. I'm not really planning. No. It's a valid test, so We should have a test valid increment syntax as well. Okay. Error bad increment syntax. Error bad increment syntax. Seems to work just fine. Okay, unit testing. I might have to step through this. I can't really see what's going on here, so debug. Oh, it's working just fine. Oh my God, thank you. Okay, so I was curious how bad the damage was, and it's not negligible. I mean, it's not like absolutely outrageous or anything, but it's not like I would want to do that, 50 times a day. Personally, I think that was worth it, rather than trying to make those by hand, just for the experience of saying that we did it. But, it is something to keep in mind. Now, how much more would it have been if we had done all of those calls with Opus? I think we made the right call not using Opus, especially considering that Sonnet did a pretty good job. It's really late. I'm not implementing the engine tonight. And besides, I'm not implementing the engine. I'm going to ask AI to do it. So what I want to do is I want to get to defining game state. And I don't want to have to worry about the back end. So hopefully this is a step in the right direction. Anyways, see ya.